This particular model will examine three relatively recent additions to the Java language. They are enumerations, autoboxing, and annotations. Annotations are also referred to as metadata. Each of these expands the power of the language by offering a streamlined approach to handling common programming tasks. We'll also discuss Java's type wrappers and give a brief introduction to reflection. Enumerations. What is enumeration? Java versions prior to J2EE lacked one feature that many programmers felt was needed, that is, enumerations. An enumeration in its simplest form is a list of named constants. In Java, an enumeration defines a class type. Also, an enumeration can have constructors, methods, and instance variables. When to use an enumeration or even. Sometimes we may want a variable that can take on only a certain listed enumerated set of values. For example, 7 days of a week, like Sunday, Monday, Tuesday, Wednesday, Saturday, or 12 months of a year, like January, February, March, April through December, or 7 colors of a rainbow, like violet, indigo, blue, green, yellow, orange, red, etc. Here, an enumeration variable or method or parameter can only take one enumeration constant out of the listed possible values, and these values, called as enumeration constants, are written in all caps as they represent constants. We can also use camel keys instead. Enumeration fundamentals. Enumeration is created using the keyword enum. So here is an example where I have created an enumeration called apple with 5 enumeration constants. The name of the enumeration is apple. So we call the apple as enumeration name, and the 5 constants Jonathan, Golden Dell, Red Dell, Winesap, and Cortland are called as enumeration constants. So these 5 identifiers are called as enumeration constants. So the type of these enumeration constants is nothing but apple. That is, the type will be nothing but the type of enumeration in which the enumeration constants are declared in. So these enumeration constants are also implicitly declared as public static final member of apple. They are also self-type. By self-type, I mean that they are enclosing enumeration. The only values that can be assigned to or contained by enumeration variables are those defined by the enumeration. Here is an example. In this example, the enumeration constant red del, which stands for red delicious, is assigned to the enumeration variable AP. We can also compare two enumeration constants for equality by using the equals relational operator as shown in this code fragment. Here, the value taken by enumeration variable AP is being compared with the enumeration constant golden delicious. Enumeration value can also be used to control a switch statement. Of course, here all the case statements within the switch block must use enumeration constants from the same enum as that used by the switch expression. Here is a code fragment wherein I have used an enumeration variable AP of type apple as a switch expression. Thus, I have implicitly specified the enum type of the case constant that will be used within the case statements as case labels. In this code snippet, Jonathan and WindSap are enumeration constants of enumeration apple and are the possible one is any enumeration variables of type apple can take. Also note that in case statements, the names of enumeration constants are used without being qualified by their enumeration type name. That is, WindSap and Jonathan are used directly and not as apple.windsap or apple.jonathan. This is simply because this type of enumeration in the switch expression has already been implicitly specified the enum type of the case constants and there is no need to qualify the constants in the case statements with their enumeration type name again. In fact, attempting to do so causes a compilation error. Next, when we want to display an enumeration constant in a print line statement, its name is output. For example, given this print line statement, the WindSap is being displayed. That is, this particular print line statement displays WindSap. Here is a complete program wherein we have put together all the enumeration code fragments and now it demonstrates the apple enumeration. So in this part of the code, I have created a enumeration using the keyword enum and the name of the enumeration is apple. So apple enumeration consists of 5 enumeration constants, namely Jonathan, golden delicious, red delicious, wine, sap and hotland. Next over here I have created an enumeration variable AP and the type of variable AP is nothing but it's an enumeration of type apple. Next, in this particular line, I have assigned a value which is nothing but an enumeration constant red delicious to the enumeration variable AP. So AP can hold only values of type apple. That is, it can hold only these 5 values. That is one value at a time. So I have assigned red delicious to the enumeration variable AP. So red delicious is nothing but the enumeration constant of type apple and AP is nothing but the enumeration variable of type apple. Next in this line, I have reassigned the value golden delicious to the enumeration variable AP. So previously the value held by or possessed by AP was red delicious. Now it is overwritten with a new value that is golden delicious. So both golden delicious and golden red delicious are constants or enumeration constants at apple. We also know that two enumeration constants can be compared using the equals operator. So here I have compared the value held by enumeration variable AP with enumeration constant golden delicious. Suppose they are equal, then this print line or this particular line will be printed, which displays AP contains golden delicious. We have also seen that enumeration constant enumeration can be used to control, that is, enumeration value can be used to control a switch statement. So here, all the case labels within each of the case statements must be the enumeration constants of the same enumeration. So over here, in the switch expression, I have used a enumeration variable AP. find apple. So this expression is nothing but the enumeration variable. So when I have done this, I know that there is no need for me to qualify the constants that are being used in the case statements because implicitly it is done over here. Next, if we observe the case labels, each of the case labels are nothing but the enumeration constants. So all these case labels should be belonging to the same enumeration. So here Jonathan, golden delicious, red delicious, wines have uncorked land. So all these five enumeration constants belong to the same enumeration apple, for which I have created a enumeration variable as E. This is the values and value of methods. It displays value of A is red delicious. All enumerations automatically contain two predefined methods. Lastly, they are that values and value is yellow. Their general forms are shown here. It is as follows: public static enum type values and public static enum type value of string HTML. Among these two methods, the values method returns an array that contains a list of enumeration constants, whereas the value of method returns enumeration constant whose value corresponds to the string that is passed in str. In both cases, the enum type is nothing but the type of enumeration. So we have taken up an example where we have created a apple enumeration. So the enum type will be over here. Suppose we use values on and then enum type will be apple. For an example, apple.valueOf wins. This returns wins. This program demonstrates the working of values and value of methods. In this part of the program, notice that we have used the for each kind formal to cycle through the array of constants that is obtained by calling the values method. For the sake of illustration, the variable of apples was created and assigned a reference to the enumeration array. However, this step is not actually necessary because the for could have been written as shown here by eliminating the need for all apples variable. So this is what can be done. And here we have eliminated the all apples variable. Now let us see how the value corresponding to the name WinZap was obtained by calling the valueOf method. So here I have passed a string WinZap to the valueOf method. We already know that valueOf method returns an enumeration constant whose value corresponds to the string that is passed to it. So this will be the output that we'll be getting when this particular program is being executed. It displays all the 5 constants of the enumeration apple, and at the end the value held by the enumeration variable AP is being displayed, and this variable AP gets its value through the use of valueOf method. Java enumerations are class types. A Java enumeration is a class type. That is, enum defines a class and this gives Java enumeration extraordinary power. For example, Java enumerations can have constructors, instance variables and methods, and can even implement interfaces. It is important to understand that each enumeration constant is an object of its enumeration type. Thus, when we define a constructor for an enum, the constructor is called when each enumeration constant is being created. Also, each enumeration constant has its own copy of any instance variables defined by the enumeration. For example, consider the following version of apple. This version of apple enumeration adds 3 things. The first thing is an instance variable price, which is used to hold the price of each variety of apple. The second is the apple constructor, which is pass the price of an apple, and third is nothing but the get price method. So this method returns the value of price. Next, when a variable AP is defined or declared in main, the constructor for apple is called once for each constant that is specified. Here, we need to note the way in which the arguments to the constructor are specified by putting them inside the parenthesis after each constant as shown over here. So we have specified values for each of enumeration constants. For example, 10 for Jonathan, 9 for Golden Delicious, 12 for Red Delicious, 15 for Winezap, and 8 for Portland. These values are actually passed to the parameter p of the constructor apple, which then assigns this value to price. Again, the constructor is called once for each constant. Because each enumeration constant has its own copy of price, we can obtain the price of specified type of apple by calling the getPrice method. So I have invoked the getPrice method over here within the main. So for example, in main, the price of WineZap is obtained by the following call. We can also obtain prices of all varieties of apple by cycling through the enumeration using the for loop. So I have used the for each loop over here, and by it I have created a list of values which represents the price. Later on I am printing the price of each apple over here in this print line function. So because there is a copy of price for each enumeration constant, the value associated with one constant is separate and distinct from the value associated with another constant. So this is a very powerful concept and is only available when enumerations are implemented as classes, that is done in Java. So when you execute this particular program, this is the output will be given. In the preceding example, we had only one constructor, but an enum or enumeration can offer two or more overloaded forms of constructor, just as any other class. For example, in this version of Apple, we have two constructors. The first constructor is over here. So this constructor initializes the value of price to p parameter, and the second constructor, which is a overloaded or a default constructor, initializes the price to -1 to indicate that no price data is currently available. Note that note that in this particular version, the red delicious is not given an argument as Jonathan, Golden Delicious, Winesap, or Cortland. That is, here I have provided values for Jonathan, Golden Delicious, Winesap, and Cortland as 10, 9, 15, and 8 respectively. But for Red Delicious, I haven't specified any argument. So this means that the default constructor is being called for Red Delicious. So the Red Delicious price variable will be initialized with the value -1 in this particular example. There are two restrictions that apply to enumerations. The first restriction is an enumeration cannot inherit another class. The second restriction is an enum cannot be a superclass, which means that an enum cannot be extended. Otherwise, enum acts much like any other class type. The main point that is to be noted is each of the enumeration constant is itself an object of the class in which it is defined. Enumerations inherit enum. All enumerations automatically inherit one class, that is java.lang.enum, and this class defines several methods that are available for use by all enumerations. Some of the methods of enum class are ordinal method, compare to method, and equals method. First we'll see what is ordinal method. Ordinal method. To obtain a value that indicates an enumeration constant's position in the list of constants, we can use the ordinal method, and this value is called as ordinal value. The ordinal method is invoked as shown here. So this is how we'll be invoking the ordinal method as final int ordinal. This returns the ordinal value of the invoking constant. The ordinal values begin at 0. Thus, in the Apple enumeration, Jonathan has an ordinal value of 0, and Golden Delicious has an ordinal value of 1, and Red Delicious has an ordinal value of 2, and so on. The next method is the compare to method. We can compare the ordinal value of two constants of the same enumeration by using the compare to method. It has the following general form, that is final int compared to enum type e. Here enum type is the type of enumeration and e is the constant that is being compared to the invoking constant. We always need to remember that both the invoking constant and e must be of the same enumeration. Next, If the invoking constant has an ordinal value less than the is, then compare to method returns a negative value. And if the invoking constant and e has the same ordinal value, then the compare to method returns a 0. And if the invoking constant has an ordinal value greater than is, then the compare to method returns a positive value. Next, we'll look into the equals method. We can compare for equality an enumeration constant with any other object by using the equals, which overrides the equals method defined by the object. Although equals can compare an enumeration constant to any other object, those two objects will be equal only if they both refer to the same constant within the same enumeration. Simply having ordinal values in common will not cause equals to return true if the two constants are from different enumerations. Here is an example. So here I have two enumeration variables AP and AP1. So I am comparing for equality, that is I am checking for equality. So this can be checked only if AP and AP1 are enumeration variables of the same enumeration. We can also compare two enumeration references for equality using the equals symbol. An example is over here. So here AP is the enumeration variable and AP1 is another enumeration variable. Both AP and AP1 are enumeration variables of enumeration apple. So I can compare AP and AP1 using the equals operator. Here is an example program that demonstrates the usage of ordinal method compared to method and equals method. So in this particular part of the program, enumeration is being declared named as apple with 5 enumeration constants. Here I have declared 3 enumeration variables of type apple, namely AP, AP2 and AP3. In this part of the program, I have used the for each style for loop to cycle through the array of constants obtained by calling the values method. So I have created a list of enumeration constant named as A. Later on, I am using the ordinal method to print the values. So here the ordinal method prints the position of each enumeration constant in the list of constant. Next, for all the enumeration variables, namely AP, AP2, AP3, I have assigned enumeration constant, namely red delicious, golden delicious, and red delicious. All these three enumeration constants belong to the same enumeration apple, and these enumeration variables are of type apple. These enumeration variables can hold only values, that is enumeration constant, that belong to apple. Next, in this part of the program, in these two parts of the program, I have used the compare to method. This is to compare the ordinal values of two constants of the same enumeration. So here I am comparing AP, which is the invoking constant, with AP2. AP and AP2 are the variables, that is enumeration variables of the same enumeration, that is AP and AP2 are enumeration variables of type apple. So here I am comparing whether AP and AP2, that is invoking constant AP's value is less than AP2. Next, that is whether its difference is less than 0, and here I'm comparing whether the difference is greater than 0. And over here I'm comparing whether both the constants are equal. So these three comparisons are done using the compare to method. Next, the next part of the program, that is the last part of the program, I have used the equals method. So I'm comparing the invoking constant AP with the AP2, that is this should be an enumeration variable. So here AP is the invoking constant, so its value is compared for equality with AP2. Next, I have compared AP with AP3. So as AP and AP3 have the same values, it will print that red delicious equals red delicious. Next, over here, we have seen that we can compare two enumeration references for equality by using the equals to operator. So I have tried out it over here and compared AP with AP3. So as both AP and AP3 have the same value, red delicious, which are being assigned over here, it prints that red delicious equal to red delicious. So this is the output you will be getting when this program is being executed. Here is an example program that can be used to analyze the concept that we have learned until now. This example program I just leave for you to analyze. Now a quick recap on all the concepts we have learned about enumeration. So under this we have learned what is enumeration. Next, under enumeration fundamentals, we have learned how to create an enumeration, how to create a enumeration variable, and how to assign values to enumeration variable. We have also learned how to compare two enumeration constants and how an enumeration value can be used to control a switch statement. In this particular topic, values and values of methods, we have learned that these two methods are predefined methods that will be available for all enumerations. Java enumerations are class types. Java enumerations as a class type provides the extraordinary power. So we have learned about the extraordinary power provided by enumeration as a class type. That is, it can contain a constructor, instance variable, methods, and even implement interfaces. Next, we have learned that enumerations inherit enum class. And we have also looked into three methods that are provided by the enum class, like ordinal, compare to, and equals method, and the benefits of using those methods. And lastly, we have taken up an enumeration example.